Good morning, everyone. Thanks for joining us. My name is Justin Whitley. I'm the National Accounts Manager with Drylet. Been here for a little over a year. A little bit about my background, bachelor's and master's from North Carolina State University in animal science. Spent quite a bit of time in the livestock arena, most recently in nutrition sales before joining Drylet, like I said, about a year ago. We also have Michael Holt, our VP of Business Development, with us today, and he will be available and joining us in the Q&A session after the presentation. So we'll try to keep this relatively brief this morning. We just want to give you an overview of who Drylet is, what our product is, what our process is, and how we can help you minimize your dredging cost. So we're going to talk about a biological dredging solution that provides predictable, cost-effective waste solids management. And we also obviously welcome the opportunity to have follow-up meetings to talk more specifically about your situation. As I mentioned, this will be relatively brief this morning. So on the next slide, we're going to show a quick video of some of the previous projects that we've done, some before and afters, to give you an idea of what we're talking about with our biological dredging solution, BioDredger. So who is Drylet? Just a snapshot of who we are and what we do. We are a biocatalyst company with a biocatalyst that accelerates biological processes. We, at this point, are active in 4 segments: biogas augmentation, helping to improve hydrolysis and produce more biogas; industrial and wastewater solids remediation, which we'll focus on today; the livestock segment, helping to break down solids in manure storage systems; and then municipal wastewater. We are very proud of the fact that we do have several awards over the years for our technology, and you can see those listed there. We do have a growing presence in both the US and in Europe, and at this point we use outsourced manufacturing in the US. We have a very good partner that we work with, and the partner does the mixing and the blending for us and then ships the product to the customers. And obviously we do have a very strong, dedicated team that we're very proud to work with. So breaking down into those markets a little bit and focusing more on the biosolids and industrial solids, we do see regularly a biosolids reduction in these lagoon systems by up to 50%. And that is both total solids and volatile solids, and extremely competitive alternative to mechanical dredging. I think most of the time we see mechanical dredging costs be in the neighborhood of $250 per dry ton plus, and most of the time we are in the $75 to $125 range. So obviously 50% or better cost savings to you, and also without interruption of your daily operations at your plant. No capital expenditures or facility modifications required. We come in and do the treatment ourselves. There's no equipment required, no permanent equipment required. And again, we're active in the North American and European markets for going on 9 years now. So the product is BioDredger. It's a biological dredging solution, again, in contrast to the mechanical dredging solution, providing predictable results for a long-term solution to waste solids. You're able to regain that lagoon capacity with no disruption to the water treatment. If anything, there's improved treatment and establishing a positive microbiology and microbiome in that lagoon, avoiding the excessive mechanical dredging costs that we talked about. You don't have to worry about lining up, hauling, and paying the tipping fees for disposal of those biosolids. And again, it's a sustainable long-term management solution rather than paying for mechanical dredging year after year. So a little bit more into the science and the technical side. There are factors that impact microbial effectiveness. What food is going into that system, the pH, the temperature, the sludge age, hydraulic retention time. All these things listed here have an impact on the lagoon treatment, the wastewater treatment that you get in those lagoons. So the microbes are the ones that are responsible for that treatment, and any of these being altered can affect it, how well they do at treating. A lot of times altering these requires significant operating expenses and capital expenses. Drylet solution with BioDredger doesn't require any CapEx, and it is a very effective solution that uses natural occurring microbes to accomplish the goal of sludge reduction. So to give you an idea of what the product looks like and what it is, there are two ingredients, a food grade silica and the liquid microbe culture that are blended together. So you get the millions of particles loaded with billions of microbes, and delivers those microbes into the sludge layer where they need to be. The product is heavier than water, so it sinks through the liquid layer and gets down into that sludge layer. And the media, the silica, protects the microbes from hostile microorganisms and chemicals, allowing them to arrive alive, ready to work, and proliferate throughout your system. It is customizable with different microbes with different remediation abilities. We are relatively agnostic to the type of bacteria that are there. We do have a consortia that we have selected to this point that we have found to be very effective, but we can work with that as well. So the microbes' access to food is made more efficient by the combination of the liquid microbes and the silica. Again, that product is heavier than water, so it sinks through the liquid, gets down into the sludge layer where we need it to be. There is an amazing amount of surface area in 1 pound of this product, enough surface area to cover 154 basketball courts. So we're not talking about just the surface area of a tennis ball. We're talking about a lattice work and the nature on the inside of that product. As you can see on the bottom left-hand corner, scanning electron microscope image of the inside of the silica particle with the microbes attached. So we're really increasing the surface area, giving those microbes a place to hide and be protected, as I mentioned, from chemicals and other macrophages, as you can see in image B there. And again, and a very important thing to point out, compared to a lot of the liquid and powder products on the market, this product does sink, it does get through that liquid layer and gets down into the sludge layer and activates very quickly. So we'll go through a few case studies here that we've done with previous customers. In this particular case study, 51% total solids reduction in a 5 million gallon lagoon, accomplished by dosing 1,800 pounds of BioDredger into that lagoon, in this particular case at a rendering site. So our typical process is that we will come in, mix the lagoon, take a composite sample, rather than just going to the side of the lagoon or going to the inlet and taking a sample. We want to get a composite sample of what is in the entire lagoon. So we want to do a good mix, take that sample, do the treatment, and then come back later and mix again, and take another sample. That way we have two snapshots as to what was the total solids and volatile solids when we started, and then what was it at a point in time later on, generally 3 to 4 months later. And again, in this case, this lagoon, we achieved a 51% reduction of total solids and 50% reduction in volatile solids, as proven. And you know, it's really great when you have the ability to add not only the qualitative, you know, you can walk out there and obviously see the difference, but adding that quantitative piece to go along with it. Generally, when we have these projects, we see somewhere in the range of 500 to 750 pounds total solids reduction per pound of product added. So in this particular case, there was 469 dry tons of solids removed, which comes out to 521 pounds of total solids removed in this case. So case study number 2, more of the same. You can see the image there. dose 3,300 pounds in this 5 million gallon lagoon. And the dosage rate will depend on what we estimate to be the total solids beforehand. We will take an estimation based off of your historical data, what you're sending into that lagoon. We will do some engineering to figure out exactly what that dose needs to be. Just wanted to point that out because there's a difference between the previous slide and this slide on a very similar size lagoon. So this case was a little bit worse than the other one, so we had to dose more. And again, use the industrial mixer for pre and post treatment sample collection. And also that mixing does help with product dispersion into the lagoon as well. So in this case, even better, 58% total solids reduction and 60% volatile solids reduction. A little over 1,000 dry tons of solids removed, which came out to 653 pounds of total solids removal per pound of biodredger. This case is a little bit different. The previous two were at rendering operations. This is at a swine farm in the Midwest with a very large, one of the top 5 swine integrators in the US. This was a 2-year dosing program. They had previously been altering between our product and another product, thinking that that was giving them a better benefit. These lagoons are very large, 15 to 20 million gallons. So we set out to test their theory, basically. So in 2020, all 4 of these lagoons were treated with our product and noted by M2 on the slide. In 2021, 2 of them were again treated with our product and 2 were treated with a competitive product. And as you can see, there was a significant outsized benefit of treating with the M2 product in back-to-back years. 55% total solids reduction, 57% total solids reduction compared to 23 and 35 in the lagoons that had the competitive product to use. And just wanted to note that the competitive product is a liquid product. So we think that definitely adds to our proof that getting the microbes down into the sludge layer through the liquid layer has a significantly outsized benefit. Most of these bacteria have a specific gravity around 1, and so they have a tendency to float rather than to sink. And that is the benefit of our technology, our patented technology of delivering these microbes down into the sludge layer. So with that, I'll take any questions that we might have. One question that we do get in situations where either the lagoon is too small or the banks are too steep, or maybe there's a cover on the lagoon and we can't do the mixing, the product is still effective. You may not see as quick a results as you would if we were to mix it ahead of time, but the product, once it gets down into that sludge layer, we're seeing a mass to gas conversion. So it's breaking down those solids and it's producing gas. And as it produces those gas, you'll see big plumes come up, as you saw in the video earlier. In some cases, it almost looks like the lagoon is bubbling. So, or almost looks like it's boiling. Rather, it's definitely bubbling. So there will be some natural mixing that occurs on its own, and the product will certainly still have effectiveness.